Good morning, students. This is Latif sir. Today I'll discuss about the chapter 7 of class 9 chemistry. The topic is study of gas law. This is the last chapter according to the reduced syllabus. In this chapter you have to read about behavior, different types of behavior or characteristic properties of gases, and about some gas laws. Okay. So first see introduction. What is gas? Depending upon the values of intermolecular force of attraction and interparticle space, matters are classified into three classes: solid, liquids and gases. And in this chapter you have to read only about gases. Okay, so gas is the this is the one state of matter. Gas is the state of matter in which interparticular force of attraction is very weak and interparticle space is very large. As the interparticular force of attraction is very weak and interparticle space is very large, the gas molecules or particles of gas become completely free to move randomly in entire available space. And all gases show uniform behavior under similar condition of temperature and pressure, irrespective of their chemical nature or their color or their order. Now see behavior and characteristic properties of gases. Behavior and characteristic properties of gases. Gas molecules are composed of very small particles, that is which are molecules, and these particles or these molecules are in random motion. And kinetic molecular theory of gases explain the different behaviors and characteristic properties of gases. So using kinetic molecular theory you can explain different behaviors and characteristic properties of gases. So first characteristic properties, composition of gas. Composition of gas. Gases are made up of very teeny particles or molecules, and these particles are moving in all possible direction at all possible speed, and the molecules are negligibly small in size as compared to the volume occupied by the gas. Next property is or characteristic is gases have neither a fixed volume nor a fixed shape. Gases have neither a fixed volume nor a fixed shape. They attain the shape of the containing vessel in which the gases are kept. Okay, so gases have neither a fixed volume nor a fixed shape. There is a negligible force of attraction between the particles of gas molecules, that, and therefore the particles of gas molecules are free to move in all in the entire space available to them, and their movement is restricted only by the walls of the container, and thus the gases attain the shape of the containing vessel. That means the shape of gas means shape of the containing vessel. Okay, they don't have a fixed shape, and they don't have a fixed volume also. Next, characteristic properties: gases exert pressure in all directions. Gas molecules are in random motion, and the molecules of gas, they are in random motion. That's why they are colliding with each other, and at the same time they are colliding with the wall of the container, and due to these collisions gas molecules exert pressure. Next, property for gases are highly compressible. This is because the intermolecular force of interparticle space or intermolecular space in case of gases are very small, very high. Okay, gases are highly compressible. This is because the interparticle. This is due to the large interparticle spaces between the gas molecules. Gases are highly compressible. There are large interparticle or intermolecular spaces between the gas molecules, and this accounts for the high compressibility of the gases. On applying pressure, the gas molecules come closer and thus decreasing the volume of the gases. Next, gases are highly expansible. Gases are highly expansible. Gases increase in volume or decrease uh, increase in volume on decrease in pressure and increase in temperature. If you increase temperature, you'll see that the volume of gas will increase. Okay, similarly, uh, on decreasing pressure, the volume of gas will increase. So when pressure on an enclosed gas is reduced, its particles, that is molecules of the gas, move apart from each other and thus increasing their intermolecular spaces. As a result, the volume of the gas increases. So on decreasing pressure, the volume of the gas will increase. Similarly, if you heat a gas, that is when an enclosed gas is heated, kinetic energy of the gas molecule increases. Thus, the molecules start moving faster and further apart from each other, and resulting in an increase in the volume of the gas. Okay, so increasing temperature or decreasing pressure, you can increase the volume of the gas. That's why gases are highly expansible. Next, density of gas. Gases have low density compared to solid and liquid. This is because the number of molecules per unit volume in a gas is very small as compared to solid and liquid. And gases have large intermolecular space between their molecules, therefore gases have very low density. Next property is characteristic behavior. Gases have a natural tendency to mix with one another, which is also called diffusion. Gases have a natural tendency to mix with one another, which is also called diffusion. What is diffusion? It is the process. It is the process of gradual mixing of two substances when they kept in contact by their molecular motion. Okay. So diffusion, in case of gas molecules can diffuse with each other. So gases have a natural tendency to mix with one another, which is also known as diffusion. And the interparticular particle or intermolecular space in a gas is are very large. And when two gases are brought in contact with each other, their molecules mix with each other. Their molecules mix with each other in such a manner that a homogeneous gaseous mixture is formed. Okay, and this intermixing of two or more gases, is known as diffusion. And the cause of diffusion is large interparticle or intermolecular spaces in case of gas. Okay. Next, gases can be liquefied. Gases can be liquefied on cooling the gas, or or applying very high pressure on the gas. You can liquefy a gas. Okay, so gases can be liquefied on cooling. The kinetic energy of the gas molecules is reduced, and on applying pressure on a cooled gas, the molecules come closer, and hence the intermolecular space get reduced, and there is an increase in the number of molecules per unit volume, and thus the gas liquefies. So on cooling and further applying high pressure on a cooled gas, you can liquefy a gas. Now see molecular motion and relationship of temperature, pressure and volume. Between temperature and relationship of temperature, pressure and volume. According to kinetic theory or kinetic molecular theory or kinetic molecular model, particles of gases or molecules of gases, molecules of any substance are in constant random motion. So they possess some kinetic energy as they are in random motion. Okay, and the average kinetic energy of particles in case of gases, especially in case of gases here, the average kinetic energy of particles or molecules is directly proportional to its absolute temperature. So the kinetic energy of gas molecules are directly proportional to its absolute temperature. Absolute temperature means temperature in Kelvin scale. Okay, temperature in Kelvin scale. As the temperature increases, molecular motion increases. As the temperature increases, the molecular motion increases. And when temperature decreases, molecular motions also decreases. And this suggests that when the temperature is zero, the molecular motion ceases. This is the theoretical concept. Okay, when the temperature is zero, the molecular motion ceases, and this temperature is known as Kelvin temperature, absolute zero temperature. Okay, this temperature in Kelvin scale is known as absolute zero temperature. Okay, so the temperature at which the molecular motion completely ceases, theoretically, this is a theoretical concept. When the temperature at which the molecular motion completely ceases on the Kelvin scale is called absolute zero temperature, and you have to remember the value of absolute zero temperature, and it is equal to minus 273 Kelvin, minus 273 Kelvin in Kelvin, minus 273 degrees Celsius. In Kelvin scale it is 0 Kelvin, or in Celsius scale, on Celsius scale it is minus 273 degrees Celsius. So absolute zero or 0 Kelvin is equal to, absolute zero also called 0 Kelvin, is equal to minus 273 degrees Celsius. And temperature lower than absolute zero, that is 0 Kelvin or minus 273 degrees Celsius, are not possible. And gas molecules exert pressure on the wall of the container. This is because they are colliding with the wall of the container. Okay, so when a gas is enclosed in a vessel, it exerts uniform pressure on the wall of the containing vessel, and the reason is that the particle of gas molecules colliding with each other and colliding with the walls of the containing vessel. And since a large number of gas molecules colliding with the wall, so they exert pressure. Okay, they exert appreciable force on the wall. So the force exerted on a unit area of the wall of the vessel is equal to the pressure of the gas. So what is the gas pressure? The force exerted on the unit area of the wall of the vessel is called the pressure of the gas. Okay. But when the temperature of the gas is increased, keeping the volume constant, when the temperature of the gas is increased, keeping the volume constant, the average kinetic energy of the gas molecule increases, and therefore average speed of the molecule also increases. And the molecules now strike with the wall of the container with greater momentum, and the rate of collision of the particles also increases. Thus, the force exerted on the wall of the container increases, and which result in an increase in the pressure exerted by gas. So, on increasing temperature, the pressure of the gas increases. Okay, on increasing temperature the gases will exert more pressure on the wall of the container. Similarly, so how to increase the gas pressure on increasing temperature? Okay, similarly, if you decrease the volume of the container, if you decrease the volume of the container, gas pressure will increase. Okay, thank you, students.